Today we're going to take a look at the properties of logarithms. So when we have any positive numbers, x, y, and b, as long as b does not equal 1 because the base of a logarithm can't be 1, and we can have any real number for n, the following three properties will hold true. Okay? So log base b of xy can be split into two separate things. So when there is a product inside, so think of there as being parentheses right here, when there's a product there, we can rewrite this as log base b of the first part of the product plus log base b of the second part of the product, okay? So a product inside a logarithm can be split into the sum of two logarithms, okay? So then when there is division on the inside, like you see in this second one, you can turn that into a subtraction problem. This will be log base b of x minus log base b of y, okay? And then for the third one, if there is an exponent on the inside that applies to the entire inside, in this case the exponent n applies to the x, that can be pulled out in front to become n times log base b of x. And these properties come in really handy when it comes to solving equations, but first we need to get comfortable using them. So we're going to take a look at some numerical examples first. So the two values, log base 4 of 5 and log base 4 of 15, are provided to us. And you can see those up at the top here. We can use those to try to manipulate and figure out the value of some other logarithms that are log base 4 that can be created using 4s, 5s, and 15s. Okay, and we can use 4s because it's a log base 4. Okay, so this first one, log base 4 of 75. I need to take that 75 and rewrite it in terms of a 5 and a 15. Okay, so this is log base 4. 75 is the same thing as 5 times 15. Okay, and because 5 times 15 is 75, because I can split that into a product of two numbers that I already know how to deal with, I can write this now as log base 4 of 5 plus log base 4 of 15 by applying that product property. Okay. Now log base 4 of 5 was provided to us up here, so we can replace that by 1.161. And then the log base 4 of 15 was also provided to us up here, so that's 1.9534. And if I add those two values together, I get 3.1144. So that means that log base 4 of 75 is equal to approximately 3.1144. Okay. So now I've got to figure out, well, how can I use the same 5 and 15 to get down to a value of 3? Okay, so when I'm looking at log base 4 of 3, I want to do log base 4, and I need to find a way to come up with 3. Well, 3 is the same thing as 15 divided by 5. Okay, so that means I can split this using the division property. So log base 4 of 15 minus log base 4 of 5. And again, those were the two values provided to us. So this is 1.9534 minus 1.161. And again, these values are provided to us by a calculator. We'll talk more about how to get them in a calculator later. So this comes out to 0.7924. So log base 4 of 3 is approximately 0.7924. All right, let's look at two more. All right, for this third problem, again, we have the same two values up at the top. We've got to figure out how to get to 125. Okay, well, 125 is 5 times 5 times 5. So I can rewrite this as log base 4 of 5 to the third power, because 5 to the third power is 125. And that third property, we'll call it the power property, says if there's an exponent inside, it can come out in front as a coefficient. So this is really 3 log base 4 of 5. So this is 3 times log base 4 of 5 is the 1.161. If I multiply that by 3, I get 3.483. So log base 4 of 125 is approximately 3.483. All right, in our fourth and final example, you see a 25 and a 16. Okay, now 16, I can't make a 16 out of a 5 and a 15, but I can get a 16 out of a 4. So if the number that you're trying to get is related to the base somehow, you can use that because we know how to find exact values when bases match. Okay, so the first thing I'm going to do is I'm going to split this apart. I'm going to make this log base 4 of 25 minus log base 4 of 16. And I can do that because of that division property. All right. Now the 25 can be written as 5 squared. So I'm going to make this log base 4 of 5 squared. And the 16 can be written as 4 squared. Log base 4 of 4 squared. Okay? And that is something that we can do exact value for because the bases now match. Okay? This first one, I'm going to pull out the 2 and make this 2 times log base 4 of 5 minus, well, log base 4 of 4 squared. We talked about how inverse things kind of cancel each other out. So because this and this match, this is going to disappear completely and just give me the 2. Okay? So now I'm going to have 2 times log base 4 of 5, which was 1.161, and then subtract 2 from the other part. This is going to come out to 0.322. Okay? So that's applying the properties of logs to find a new numeric value.